86 when we're done. So remember, we started when I started sprinkling the trig stuff in this semester, we started talking about the unit circle. But I tried to make it clear every time we talk that not every circle is a unit circle. And we kind of go back and forth between using a generic circle and a unit circle. And so we're back to not necessarily unit circle stuff right now. So this is coordinates of a point. So really of any point, it could be a unit circle, but not necessarily. Circle centered at the origin. Okay, so we're right there. Give it an angle theta in standard position with radius r. So that kind of tells me for sure it's not necessarily a unit circle unless r is 1, but r could be anything. And so that's what we have here. And it shows me here that my radius is r, not necessarily 1. This is how I know for sure it's not necessarily a unit circle. When we did talk about the unit circle and we discovered how all this stuff kind of fit together, we were writing our XY ordered pair as cosine theta, sine theta, right? Because it was a unit circle. But we know that cosine isn't always just x. It is x over r, and sine is y over r for any circle, including the unit circle. And so if I want to actually solve for x and y here, I would multiply both sides by r. So I would get r cosine theta equals x, and y, no, God, I did that wrong again. R sine theta equals y. So where we were saying x is cosine, y is sine, still the truth, because if r is 1, that's why it just ended up like it was. If r is not 1, we just multiply it out front, and that gives us our ordered pairs. If you are in AP Physics, this is your mg cosine theta, mg sine theta for your magnitude with your vectors and whatnot. So it all kind of relates together. Is that kind of what y'all are doing now? Or you're shaking your head like, are you in AP Physics? Are y'all doing that right now, or did you do it a long time ago? That was the first. Okay, that's what I thought. And that's what sucks about how we don't line up, but it's just how it is. So, and so then our coordinates, instead of just being cosine theta, sine theta, it's r cosine theta, r sine theta. Okay, so not a big change, right? Just a little bit of an adjustment if it's not a unit circle. So we just got to pay attention to what we have. It's always very clear in telling you, excuse me, either flat out telling you or always look at this ordered pair right here, because that'll tell you. I mean, if it's 1, 0, it's a unit circle. If it's not 1, 0, it's not necessarily 1. Okay, so let's look at some of these questions. This one here says the figure above shows a circle of radius 4. So it flat out tells me. If it did not, I look at this and I can see that my radius is 4. Okay, and then we have an equilateral triangle PQO, which are the following coordinates of point Q. Okay, so before I worry about this, because me just trying to guess at an answer and figure that's not going to do me any good. I got to think about it is an equilateral triangle. What do we know about an equilateral triangle? What's true about it? All sides are equal. What else? All angles. So all angles and all sides are congruent, right? They're all the same. So that means, and I kind of already knew that these two are congruent because they're the radius, right? But then this one is as well. Since all 3 angles are congruent, what does the measure of each angle have to be? 60, right? Because there's 180 degrees. So this is 60, this is 60, this is 60. We all agree with that? If all of that is true, then what is this measure right here? 30, right? That would be 30. Does that make sense? Okay, so then if that is 30, that makes this right here 60, but in radians, what would that be? Pi thirds. So this is pi thirds. Everybody with me on that? So I used my knowledge of the triangle, which is prerequisite knowledge, to figure out an angle on the circle, which is not even the angle I actually want, but it's going to get me there, because I need it over here at Q, but we're getting there. Okay, I need it to be at Q. So this right here is pi thirds, because this is 60, and then this is another 60, right? So that means if this is pi thirds, what gets me all the way over there? 2 pi thirds, exactly, because it's 2 of them. Even if I don't know that 120 is 2 pi thirds, that's fine. If I have pi thirds and another pi thirds, that gives me 2 pi thirds, right? Everybody with me on that? So that's the angle I'm looking for there. And then I know that my ordered pair is r cosine theta, r sine theta. They told me 2 different times, excuse me, what my radius is. It is 4. So that means I'm going to have 4 cosine theta, or cosine of 2 pi thirds, because that is my theta. And then 4 times sine theta. This is not even asking me, oh, sorry, can't talk and write at the same time, apparently. This is not even asking me to evaluate cosine and sine of 2 pi thirds at this point. I mean, yeah, there are going to definitely be times where we have to, but here I just have to understand how to do it. Now, that looks like answer choice C. However, I know that in the second quadrant, my ordered pairs are negative positive, right? And that one's negative positive. I'm pretty confident I can get rid of those, aren't you? But let me ask you this. Just cosine of 2 pi thirds. Is that value positive or negative? Is the cosine in the second quadrant positive or negative? Negative. So this value is negative, right? So if I take a negative value and multiply it by a negative number, this becomes positive, right? And my x value can't be positive. So even though this looks good because it's negative positive, it doesn't make any sense because I know I don't see negative positive here, but this is positive times negative, and then this is positive times positive. Does that make sense to you? So don't start trying to confuse yourself and overthink things, because the values that you have in there will make the ordered pairs come out correctly, even though it looks like a positive positive. Okay. And that's the trap you fall in sometimes when you don't just figure out what you know and you start trying to overthink and you're like, oh, it has to be negative positive, and you're not really thinking about what's there. Okay. What questions do we have? And just because we have an equilateral triangle or something in there, don't just go like, I don't even know what to do. Do the same thing. Like, and I guess I haven't said that this much this year. My voice should haunt you. Okay. Not necessarily in a bad way, but like, when you are stuck on something, I want you to ask yourself the exact same questions I ask you. That's why I do that. Like, what do I know about an equilateral triangle? Well, if this is 60, what is this? Like, try to ask yourself those questions, and it'll get you past places where you're stuck at, okay? All right. Here we go. The figure shows, or any other questions on that one? I'm sorry. Skip over it. The figure above shows a circle of radius r. So radius r, and that's what it says right here. So not necessarily a unit circle. Could be, but I don't know. Along with the line y equals negative x, the circle and the line y equals negative x intersect at these 3 points, okay? Coordinates of P are 6 square roots of 2 and negative 6 square root of 2. What is the value of r? Okay. So this is one of those cases where maybe not you at this point, but when I first read this question, I thought it was going in one direction, going to ask me something, and then I was like, I don't know that I would apply it that way. And then I was like, well, I could do it a different way. So I did. I'll talk about where I thought it was going when we're done. But I know that if I have an ordered pair, that I can draw a triangle in. Remember, you always just go perpendicular to the x-axis. Think about those little triangles we taped in. That's another reason why we did it, because I don't want you trying to connect it to the y-axis. That's not how we taped them on our circle. And if this is this right here, that means this is 6 square root of 2, this is negative 6 square root of 2, and this is the radius. So what can I do to figure that out? Think 6th grade. Pythagorean theorem, right? It's just a right triangle and I have a missing side, yes? So 6 square root of 2 squared plus negative 6 square root of 2 squared equals r squared. Okay, so I'm going to give you a minute, and I want you to actually square those out on your own. You can talk to your neighbors about it. That would be great. But I don't want to just do it for you, because this is one of those things I feel like I have to reteach every single time it comes up. Okay? It's not because it's crazy hard. Check with your neighbors, see if y'all agree. I'm going to get my water. Think about your exponent rules. Don't make up math. Very good. All right, is 6 squared a 2 squared? Does that give me 12? No. If you write it like this, that gives me 12, right? Or even if you wrote it like that, but if you're using a calculator, most of the time y'all type it in the calculator wrong and it gives you 12, and it's a calculator, so you're like, it has to be right because it's the calculator, but no. All right, so when I square 6 squared to 2, what do I get? When I square this number, what do I get? 72. Because I square the 6 and get 36. I square the square root of 2 and get 2, and I multiply them together. That's where 72 comes from. Okay? We don't necessarily square stuff like this a lot, but when we do, we have to get it right. Okay? And again, think about your exponent rules. If I have xy squared, doesn't that become x squared, y squared? Yes. If this confuses you, or if you know you mess up on stuff like this all the time, or it confuses you, don't go straight to here. Do this. 6 squared to 2 squared, and then make it just like you would there. 6 squared and the square root of 2 squared, and that will probably make more sense to you. And it's fine to do an extra step if you need to. Some of you need to, some of you don't. Whatever. It is what it is. Okay? And so then this is 72 plus 72. That's r squared. So r squared is 144. When I take the square root, I get plus or minus, but the radius is always positive, so r is 12. Okay. Now, where I thought this was going, and I was even thinking, I'm not even sure how to force it down that road. There probably is a way that I'm just not seeing right now, but let's just pretend like they didn't even give me an ordered pair. Okay, so just kind of ignore all the information they gave me except for this. Okay, and I want to say that this is theta. Okay, and this is all they told me, that intersects the terminal side. So then you should be able to tell me what the tangent of theta is. What is the tangent of theta? We talked about it yesterday. I know we talked about a lot yesterday, but okay, yeah, absolutely. So tangent is y over x. Yes, 100%. It is sine over cosine and y over x. And yes, we need to know that. But the other part, because we knew that, right? And when we read it, I said, we're going to skip over the first sentence. Then we read that and talked about that. But what was the new part that I said? And how do we remember it's y over x? Because that's the same as what? Slope. Because tangent is what? Slope. Tangent is the slope of the line, right? So when you can remember y over x, just like slope is y over x, what is the slope of this line? -1. So the tangent is -1. Now, I could have also figured it out from the ordered pairs, but they didn't have to give me that because we need to connect tangent to slope, okay? Does that make sense to you? So then one more question. Oh, actually, well, let's see. I did make that theta. Really, it could have gone to here either way. It's really talking about this one, but it doesn't matter. So let me do that too. So then we'll just make this alpha. We're going to go all the way to where we're actually talking about, which is alpha. But it doesn't, alpha and theta are going to have the same tangent value, right? Because it's negative and we're there. But I want to know, based on what we know, what alpha actually is. So let me ask you this first. It is in the, well, no, just go ahead. So tell me, what do you think alpha is? What would the measure of that angle be? I mean, you can use your ordered pairs this time, not just the -1 or even the -1. Honestly, we still don't need this. We know this. What gives you a tangent value of 1? Just 1, +1 in the first quadrant. What angle measure? Pi-4, right? Pi-4 gives me a 1. So does my, and then my second quadrant pi-4 gives me a negative, third quadrant gives me positive, fourth quadrant pi-4 angle gives me a -1. What is my fourth quadrant pi-4 angle? 7 pi-4. Very good. So do you see how we knew all that other stuff, even if they hadn't told me certain things? So I really thought because they gave us the equation of the line, they were going towards this, but then that's not really what the question said. Another reason why you should read the whole question and not just assume anything. All right, any questions at this point? Okay, perfect. All right, so let's flip it over. Now we're talking unit circle again. I know that for two reasons. It says unit circle, and I have this right here, okay? And I don't even need to look at it. So instead of looking at it, I want you to just think about kind of like, you just think about an x and y axis, right? So cosine of 0, I'm here. What's the cosine of 0? 1. Sine of 0, what is it? 0. Then I'm here. Pi halves. What's the cosine of pi halves? 0. Sine? 1, right? Because that ordered pair is 0, 1. Then we're here. What's the cosine value? -1. The sine value? 0. 3 pi halves, we're here. What's the cosine? 0. Sine? -1, right? Those really should be the easiest. So just think about your corners. Before you say anything, picture the ordered pairs so you don't get them backwards. It's so easy to get them backwards. We good? All right, so I'm going to talk you through what we did. So I've sprinkled this in a little bit throughout this 6 weeks. This was kind of the second sprinkle. And how we go through all of this stuff. So sine of 2 pi thirds. The first thing we say is, all right, what quadrant is 2 pi thirds in? Second, right? It's in the second quadrant. And in the second quadrant, is sine positive or negative? Positive, because remember we have this, all students take calculus, right? So it's positive, which means all I need is the sine of pi thirds. You can use your hand. What is the sine of pi thirds? Square root of 3 over 2. Okay. B, what quadrant is 5 pi fourths in? Third. Okay, good. In the third quadrant, is cosine positive or negative? Negative. So I know my answer is going to be a negative something. What is the cosine of pi fourths? Square root of 2 over 2. Very good. 11 pi 6. What quadrant are we in? Fourth. And in that quadrant, is cosine positive or negative? Positive. All right, then what is the cosine of pi 6? Square root of 3 over 2. Okay. If you can't get these because you don't know the hand trick, that's on you, because that means you haven't been practicing. And I've said multiple times, I don't want you to say to me ever, I don't get the hand trick. If you have your own way of doing it, that's fine. But if you don't know them and you don't know the hand trick, that's a problem. And I've told you, I will really explain it to you 1,000 times so that you get it, because it makes everything so easy, right? Because you have to be able to get through this relatively quickly. All right, let's look at D. What quadrant am I in? Fourth. Good. Sine positive or negative? Negative. Good. So negative, and then what is the sine of pi fourths? Square root of 2 over 2. Very good. 4 pi thirds. What quadrant are we in? Third. Also, if you're having trouble, like how do people know so quickly what quadrant we're in, let me help you individually, and I will figure out what makes sense in your brain. So in the third quadrant, is cosine positive or negative? Negative. And then the cosine of pi thirds is 1/2. 7 pi 6. What quadrant are we in? Third. Positive or negative? Negative. And so that's a negative. Sine of pi 6 is 1/2. We good? Now, if you're rusty, but like you're getting a little better as we go through this, great. Because we're just going to go through all these together quickly, because I want you to see how quickly you should be able to think through it. And if you can't, we need to practice. But I also want to, oh my God, I want to scroll. Okay. I want to tell you that very quickly, We are going to be taking the same information and going backwards. And if it doesn't make sense to you going forwards, backwards is going to be impossible. Okay, so that's why I've been trying to get y'all to be semi-experts at this, so everything else just can kind of go smoothly for you. All right, pi, what quadrant are we in? Yeah, it's a quadrantal. So then I want to think about the ordered pair, right? That ordered pair is negative 1, 0. So then what is the cosine? Negative 1. Okay. Now the stuff that I'm writing down that's not just the answer, on your notes I want you to write it down. Do you have to write it down when you do it on your paper? No, but should they be thoughts in your head? Absolutely, or you're just not going to get it. All right, 3 pi halves. What quadrant are we in? Quadrantal, and that point is 0, negative 1. So the sign is negative 1. All right, 2 pi thirds. What quadrant are we in? Second, positive or negative? Negative, right? And then cosine of pi thirds is 1/2. All right, 5 pi thirds. What quadrant are we in? Fourth. Positive or negative? Positive. Cosine of pi thirds is 1/2. 0, what quadrant? Quadrantal. That's 1, 0. What is sine? 0. Good. All right, pi halves. What quadrant? Quadrantal. That one is 0, 1. Cosine is 0. Okay. Now remember, your delta maths, where there's a lot of this practice, different types of practice, I leave your delta maths open always. I don't close them. So you can always go back to them, and because I think this is good practice. It has some good things in it. You can just do the same questions over and over again. It's fine. And it's not going to change your grade. Like if you miss something, it's fine. Make yourself some flashcards, something, but you've got to know this stuff. Okay. And so practice some more. If you were like, dang, I got it, now I'm rusty, that means we got to think about it a little bit more often, right? We okay with all that? Because you can do this. I know you can.